Hi, my name is DuBois, and this talk is WebRTC, What's in it for me? And it's targeted at developers who already have some experience in the video space. You're using RTMP or SRT, and everything's working great, but maybe there's some parts that can be better. And this is kind of a showcase of the features that WebRTC provides and maybe how it can make your application even better. So my background is that I'm deeply embedded in the WebRTC space. So at the end of the talk, if there's anything I've missed regarding other protocols or I've made a mistake, I appreciate please submit a question, and I'd please correct me. It's more important to be right than anything else. So first off, the original project I worked on is Pion, and it's a collection of Go RTC libraries. It's kind of the building blocks to build your product or vision, and it was designed to be flexible. And it's a community-owned, non-commercial. It's purely a project that I do in my personal time. It's not an avenue to make money. And one of the biggest projects is the Peer Connection API in Pure Go. So if you're familiar with WebRTC, Peer Connection is how you connect two peers together and you exchange media. It's the Go implementation of that. We also provide a turn server, and turn is important in a WebRTC deployment. Because if you want to go via UDP, or if you're not able to do NAT traversal, you need to run a turn server. And then one of the newer projects is Ion, which is a cluster-based system for building RTC. So it's not a lower level building block anymore, but it's a full-featured media server that lets you do conferencing, it lets you do protocol bridging, and processing of that real-time media. And then a project I've been working on recently is WebRTC for the Curious. And it's a book on how WebRTC really works. If you've ever tried to learn WebRTC, you've probably seen a lot of tutorials on JavaScript APIs or C++ APIs, and this is not that. This is a book on how the actual network protocols work and the concepts behind them. Congestion control and how ICE works and things like that. And at the end, we have actually the history of WebRTC, because WebRTC is made up of a bunch of pre-existing protocols, and so I wanted to bring more light into how all these building blocks come together. And then also WebRTC in practice, debugging every piece, and I want to teach you the sharp edges so you don't run into them. So first off, what is WebRTC? Originally it was designed as a protocol between browsers. It gives you an end-to-end secure connection between peers. So if you can either connect to web browsers, or you can connect a web browser to a server and send video that way. It doesn't make any distinction about who you're talking to. It's a protocol that is peer-to-peer, but you can create client-server systems with that. It allows you to do multiple audio and video tracks. So you can send two video tracks, you can receive one audio track, you can add and remove them at any time. And then it also does binary data, and it can be lossy, it can be unordered, or it can be lossless and ordered to feel like TCP. WebRTC is also available in many, many languages. You have a Python implementation, you have a TypeScript one, you have Go, you have some commercial ones in Erlang and Java, and a Rust one is coming up right now. So WebRTC is available in lots of different places, and these aren't just bindings over one library. These are pure implementations that you can go in and read the code, and it helps you understand the protocol even better. So one of the things to understand about WebRTC is it's actually a bundling of existing protocols. So it's made up of things like RTP, DTLS, ICE, STP. These are all things that have existed since the late 90s, early 2000s, and we're working and people have been using them today. And the idea was, let's just bundle this up into something that works and put it in the browser. So now that we have all these things, we have this protocol that allows you to connect two people together. And WebRTC really moves in 4 steps. Signaling, which is the process of figuring out who do I want to talk to and what do I want to talk about. Connecting, which is actually establishing the connection. Securing, which is exchanging keys and making sure that the call is secure, and then actually sending the media back and forth. So if you're a developer right now and you're using RTMP, these are the kind of things improvements you can see if you start evaluating WebRTC for your workloads. The first thing you'll notice is probably the lower latency. So with RTMP, since it's running over TCP and a lot of times you're doing a client-server topology, you'll hit some higher times. But with WebRTC, you can expect sub 500 milliseconds. It depending on how you deploy things, like you can lower that or you can make it higher. And it's all a trade-off between quality versus latency. I can wait a second and make sure that all my video frames arrive and there's no packet loss and things are perfect. Or I can shoot for a lower time and maybe be okay with some packet loss. And Chrome is getting more and more APIs to make that even lower. So you have the play out delay hint that allows you to actually specify, like, I don't care about how long it takes for my video to arrive, like I want it to play now. And PC Gamer did an interesting review of Stadia where they pointed out that in 125 milliseconds, I can press a key and get a video frame back. So what that means is that Stadia uses WebRTC, that I can press a button on my keyboard, it can send a message over a data channel, it can encode the video frame and send it back in under 125 milliseconds. That's like the latency of sending something and receiving back. So like the video frames itself is only half that time. WebRTC is secure by default, and it's actually mandatory security. It uses DTLS and SRTP. So DTLS is just TLS over UDP that you use to access any HTTPS site, or the TLS, which is used to secure pretty much everything. And then WebRTC, it doesn't use a certificate store like a website does. You go pay a central authority and they maintain that. What WebRTC does is that you exchange a fingerprint ahead of time and say, like, hey, I'm going to try to contact you and this will be the certificate. And that's super powerful. And then the nice thing about DTLS and SRTP is a lot of this works with existing gateways and proxies. So if you've ever used asterisks, or you've ever used FreeSwitch, or you've been in the VoIP space, like bridging WebRTC with those existing deployments is super easy. Flexible networking. If you're in an RTMP space, you're used to, I'm going to upload my video to the server, and I can take it to HLS, or I can watch it via RTMP as well. But WebRTC doesn't require that. You can actually connect two peers that are inside two private networks. It uses a concept called NAT traversal, which kind of feels like an automatic port forwarding, where each WebRTC peer temporarily exposes a port in your NAT, and they're able to contact each other directly. That means the video never has to enter your network. It's better for user security because they don't have to worry about video flowing through you. It's better for you cost-wise. You don't have to pay to run all those video packets through your server. But there are cases where you want to route through a WebRTC server. So let's say like you're uploading a video and you want thousands of people to watch it. Residential network isn't able to handle that. And so what you'll do is you'll run a WebRTC peer up on a server and you'll upload video to it and fan out. The other big one is staying connected as you roam. Right now we expect a video on the move. So if you've ever watched a video while you're on the train, you'll notice that you'll hit certain points where it'll buffer or it'll completely lock up. And what's happening is as you're switching networks, the TCP congestion control either has to completely starts over, or it has to do another slow start. The nice thing about WebRTC is the congestion control is completely in user space. And so if you switch networks, it can continue at the same exact bit rate that it's been running before. And if the network conditions are the same, like you don't have to deal with those painful paths. There are other solutions, like TCP has multipath, which I'm honestly not entirely familiar with. But if you're in the WebRTC space, like being able to roam and like do the load balancing aspect of it, of moving between servers, is super powerful. WebRTC also has some great media capabilities that you don't see in RTMP. With WebRTC in the browser, you can actually upload multiple quality levels that is configurable in the browser. So I can say I'm going to upload my webcam and I'm going to upload in a low, medium, and high rate. And whatever internet you have available, it'll use. So if you have enough internet for low and medium, that's what it'll upload. You don't have to run those expensive transcoders anymore. You'll see on a lot of broadcasting sites that broadcasters will upload 1080p and then it'll transcode down for the lower levels. That's expensive and it adds a lot of complexity to your back end. If you switch to WebRTC, you can just use this. You can add, remove tracks at any time on either side. So I can actually send, like, what people are doing today is they're sending their screen share via AV1 but they're sending their webcam via VP8. It's really up to you. And then I can add or remove it at any time. In the middle of a conference call, I can add my desktop or I can remove it. I think it's great for more advanced users. What I've seen is that actually a company that was using Pion for robotics, that they would turn cameras on and off as more bandwidth came available. So they had depth sensing cameras that took a lot of bandwidth, and they would turn them off at certain times because they cared more about the front view because they were always recording it. Interesting things like that. It opens up a lot of possibilities. You don't have to hang up the entire connection. And also the bidirectionality of WebRTC. You're seeing a lot of things where people want to co-stream. So right now you're using NDI. You could just do that via WebRTC. And then it's also, the nice thing is WebRTC is still fast moving and widely adopted. You know, we have H.265, we have AV1, and unfortunately there's no single standards body that's like controlling RTMP and is going to add these things. And then WebRTC has binary and text communication. So if you want to send metadata, you know, how many users are in a room, are you chatting, stuff like that. And then it's also important because it's end-to-end secure. So if you think if a user is chatting over video, there's no reason to upload that metadata to the server. It's better for the complexity of your backend, and it's better for the privacy of the user. And the binary and text communication in WebRTC is great for real time because you can simulate like UDP-like behavior. You can say I want unordered and I want reliable, or I want unordered and unreliable, and you get rid of that H head of line blocking. So you don't have to wait for a packet in the past that got lost. And then lastly, it's a standard. It's widely available. We shared the implementations before, but C, C++, Go, Python, Rust, and then Android, iOS, all these platforms. You don't have to struggle like trying to port one code base to all these other places. And it removes subjectivity from the incompatibilities. With RTMP, you'll see that there's a lot of forks of librtmp and things like that. The nice thing about WebRTC is you have standard bodies, so the IETF and the W3C, that dictate how these things work. So it's really nice that you can just come to the projects and say, this is how things are supposed to work, submit a test, and it just works. And it's in the browser. It's so hard to get like other video protocols in the browser, and like WebRTC just makes it so easy. If on the ingest side and the playback side, it's just passed right through. And then again, like it's easy to bridge. All the WebRTC reuses all these things that we already know about. So load balancing and gateways and proxies, we can just reuse software from telephony. So what about WebRTC in an SRT world? SRT they're in the IETF, it's going through standardization, it's very modern. Like what are the kind of nice things that you can get from WebRTC? WebRTC handles the negotiation in band. So when two WebRTC peers try to talk to each other, they declare that I support X codec. So I can say like, okay, I'm willing to talk to you, but I only support H.264, so that's what this call is going to have to be. WebRTC is great in those use cases because you don't have to put all of that logic in your application itself. It's handled by the library. It's super important when you're dealing with hardware encoders. We have a fleet of devices, and maybe two of them support hardware H.264 hardware encoder. But if they don't, like we'd like to fall back to VP8. Little things like that, like really save and make your application easier. It's just another thing you don't have to debug. And then, again, it's like widely available. The nice thing about WebRTC is that you have implementations in all these languages. SRT is seeing a Rust implementation right now, which is super exciting. And then you have the reference implementation in C++, but WebRTC is widely available. And then what about RIST? That's another one that's coming up. And the story is actually like really, really small compared to that. Like RIST is actually a simpler WebRTC. It uses the same underlying protocols. It uses RTP, it can use SRTP. I haven't used RIST myself yet, but just from reading the docs and following along the standardization, the things that I think are a big difference is the optional security of RIST. RIST has protocol as actually defined profiles. So it has a simple profile, it has a standard profile. So that gives you kind of an optional security. I think it's one of those things that WebRTC I've really come to appreciate, is that I know if I'm using WebRTC that I don't have to worry about like what the security looks like, that both peers are going to use DTLS and SRTP, and there's nothing to worry beyond that. And then RIST doesn't handle the negotiation in the protocol. On each side, you have to know ahead of time, like this is the codec that I'm going to be sending and this is the codec I'm going to be receiving. The nice thing about WebRTC is that's all handled in band. You get an event and said like the other side wants to send you this stream with this codec. So this is my favorite part of these talks, is to show off open source projects that are in the WebRTC space that I find exciting. These are all non-commercial projects that I think show like the flexibility and the interesting use cases for WebRTC. So NS Remote is an agent that runs on a Nintendo Switch and forwards the video frames over your local network so that you can actually play with a VR headset on. So right now the user is watching the game that's playing on the Nintendo Switch, but they're playing within their hands. This shows off like the LAN ability to stream video frames with WebRTC. You don't have to like send it up to the internet and route it back, and also the fact that you have these SDKs that work in the Oculus headset, and then that you have nice libraries that are available to run on the Nintendo Switch. Protocol bridging is a big one with WebRTC. So this project Kerberos is using all these existing security cameras, and they're just sending this RTP traffic over the internet via WebRTC. So the nice thing is it's secure. You don't have to put your security cameras on the public internet anymore, since it's doing NAT traversal, and that's super powerful stuff. Cloud Retro is gaming in the browser but it's the NES emulator is running on a remote VM. So instead of having to run that software locally, you can keep all the game state on a remote server, and you don't have to worry about installing things locally. And then it opens up cool possibilities I didn't even realize until recently, which is stuff like gaming with friends. So since you're all sending your input into an emulator that's running in the cloud, it's super easy to do multiplayer games. It's really easy to save your state and resume games with friends. And then Nico's in the same space. It's a web browser that runs remotely that multiple people can interact with at the same time. So me and a friend can watch a YouTube video, and then in the sidebar we can chat with each other. I'm excited to see this for other things, like let's say like shopping with a friend. You can scroll in a web browser and go on Amazon or whatever you want, and you don't have to send links back and forth. I think that's super powerful and shows the sub-second time with WebRTC, and also the great use of the data channels. And then you have the drone use cases. So this user hooked up a Tello over WebRTC, and now they're controlling it by dragging the movements on the left-hand side, and they're streaming the video frames over the internet. And it's great for that NAT traversal, it's great for congestion control. You have all these features that are super powerful. And WebRTC, it's great for bridging as well between platforms. So here we have one user that's in a terminal that's watching their video frames live, but then we have the other user that's sitting in a browser. It's a protocol that bridges, and you don't have to worry about running any translation servers in the background. So this is a peer-to-peer connection. I'm not running these video frames through something to convert protocols. It's a command line process that's directly connected to another browser. cloud-morph is the ability to run a wine process on a remote server and ship the video frames back and forth. It's basically Stadia, except an open source version that lets me keep a VM running remotely, and I can run old games. I can run stuff that's maybe hard to use anymore on Windows. I think this is great for software preservation. And then out of the video space, I think WebRTC is also great for scaling and DevOps and getting more into the data center. Because right now, if I want to connect, two servers that are running in different regions, I have to use some kind of, pub sub or something to connect them together. Or you can use a VPN to connect them. But with WebRTC, I can just run that information over the internet, end-to-end encrypted, and I can have, via NAT traversal, these two servers communicating directly. or I can SSH into a server without having to go through a jump box. And the ubiquity of WebRTC makes it super powerful. So Snowflake is Tor, except running right through the data channels. So if I'm not able to download a binary, but I want to use Tor, I can just use it directly from my browser. I don't have to download anything. I just establish a WebRTC connection with another bridge, and then I'm able to route all of my traffic that hasn't been censored through another peer that talks WebRTC anywhere in the world. And the same with sharing files. WebRTC, I think, is a solution to having cross-platform file sharing that also works in the browser. So with Web Wormhole, I can share a file from my desktop and download it from my browser on another computer, and I don't have to worry about running it through a third-party service. I don't have to worry about the security implications because it's just peer-to-peer. And I love seeing this now with COVID that people can't meet in person, you have these virtual spaces. So using WebRTC, you're able to use things like WebGL and put your video on top of an avatar and move through a virtual space. And Project Lightspeed is a brand new project that lets you do sub-second streaming from OBS into the browser. So it's super nice. It's like just a Dockerized deploy, and then I can have my own broadcasting setup that's sub-second and I control it. So hopefully you found some interesting things about WebRTC, and I think those projects really kind of show off, like, these are all the exciting little spaces that WebRTC can go, and there's a lot of interesting commercial products that are showing up now that are taking these open source ideas. So please, fire me any questions. I love working on this stuff. This is all non-commercial. I just really believe in the technology and what it can help us build. And then please contact me in any of these places. The Pion project has a Slack dedicated to chatting about that in WebRTC, and we'd love to have you in there. And then feel free to email me directly anytime if you have a question that you prefer to just talk about one-on-one. So thanks for coming to the talk, and I hope to get some good questions.